Hey everybody, here's this week's Max 3D graphics tutorial, and I have a background image from the town of Havre de Grace, Maryland. I think it's in Maryland. Yeah, it's in Maryland. It's close to Baltimore. Cool little town. As we talked about in class, I made myself a patch called Physics Starter. So it's just the stuff I know I'm going to need every time I'm doing 3D graphics with physics. So let's quickly step through again and just make sure we're aware of what all of that stuff is. So first of all, up here I've got my jit.gl.render. I called my world W underscore because this is my starter patch. So every time I work with this starter patch, I'm going to unlock it and give it a unique name so it doesn't argue with any other patches I'm running. And in order to help me find those objects that take the name of the rendering context, I highlighted them in red. And I did that by selecting the objects, clicking on the Format button, and just choosing a red border for those objects. And that's a nice way to just visually pop those out on the screen. So now my render context is called W_1. So here's my renderer up here. My erase color is the background color that the world will erase to when I start the rendering. Here I have my camera, which by default is on a tripod, but I can take it off the tripod. I've just added a couple standard Adder UI objects here for things that we commonly do with the camera. Standard key to select to switch over to full screen. So that when I hit escape, I go full screen. Hit escape again, I come out of it. Then we added in the last class the jit.phys.world object, which doesn't take the name of the rendering context. It just connects via a patch cable to the jit.gl.render. You don't want to forget that patch cable. You can color code the patch cable too if you like, just to help it stand out in your patch. And as we looked at in class, there's a world box and the possibility of gravity, which is in meters per second squared. So 9.8 meters per second squared downward is equal to Earth's gravity. The world box has a scale. Right now it's 5 meters on a side. And there we go. If I zoom my camera out, I can see that I've got two grid shapes here. One is a grid shape that's showing me the bounding box of my world box. And that's just a frame because it's in poly mode 1.1. If I wanted it to be solid, I'd go to poly mode 0.0. And now it's a box I can be outside of or inside of. But in poly mode 1.1, I can see right through it. And I can also disable it and turn it off. And I also have a floor here. And I'm creating both of those with jit.gl.gridshape objects. And to make a floor, I'm using a plane shape and rotating it 90 degrees on the x-axis to make it lay down so it becomes a floor. And if I want to go over the floor and look down at it, I'll take my camera off the tripod. And I'm looking at it. You see how glary it is? That's because I've added a jit.gl material. We didn't look at this in class, but if you connect a jit.gl.material to an object and then double click the jit.gl.material object, it calls up a materials inspector that lets you choose what material your object is going to be. So I can make it dirt or pavement. I can turn down its shininess. change the way in which it renders. And so these materials will respond differently to the light. Make this a bit less shiny and maybe a bit rougher surface. There we go. Close that. So I just get to that material editor by double clicking the jit.gl.material object. I'll just mark that object with a color just so I know, hey, that's something that I double click. Also, we looked at the fact that any movie file that you drag into Max becomes a little player. So if I just search my computer for any .mov file, and grab it and drop it into my patch, it just becomes a little movie player. And I can hook that up to a jit.window. Here it is. And play my movie into that window. There's my movie in a window. That's nice. There's also a jit.p.window object, which just puts a little video window into my patch. And I can also use the this message prepend environment underscore texture to send this video to become a texture on any 3D object. So now my floor has video playing on it. And that also interacts with any choices I make in the material editor. I get the video and the graphics interacting together, and of course this is my 3D world. I can fly away from my object, fly close to it. There's a different movie. And so if I want to go back out to my normal camera position, there, I'm now looking at my floor. I can turn on or off the box that shows me my world box. Now here I have a message box, and we've talked a lot about this, right? By default, Adder UI objects do not save the information with the patch. We looked at a couple ways to do that. One way is to get info on the object and freeze it. So if we get info on our jit.phys.world, we could go, for instance, here to the world box scale, hit the snowflake button, and freeze that attribute. So the next time we load the patch, it'll open up with those values. Another thing that we looked at is to use a message box, because message boxes retain values. So if I want a message box that will allow me to change my world box to 10 by 5 by 10 instead of 5 by 5 by 5, I can connect that message box to everything I want to change, which in this case is 3 things. I want to change the size of the actual world box scale, and I want to change the size of the grid shape that's showing me the world box scale, and I want to change the size of my floor. And here I'm using a single message box hooked up to those 3 things so that I can change to different world box sizes. So if I wanted a 20 by 5 by 10. Connect it up to my 3 destinations. Click it, and now I have a very wide world, or what might be a bit more interesting would be 10 by 5 by 20. Now I have a very long, deep world. Let's see where my lights are here. Lighting it up with both lights. Some 3-point lighting. I'll pass one light off to the right, one light off to the left. And now my objects will be nicely lit. So let's see what else is in here. A couple of lights, as we see. I think that's about it. Oh, let's just take a look at this $sign argument. So why am I using this scale $1, $3 here? Well, because my floor is a plane. So it only has 2 dimensions in scale. It only has X and Z. It doesn't have a Y dimension. I mean, really it has X and Y, but since it's rotate 90 degrees, we can think of it as X and Z. And so I'm taking the 10 and the 20 from this world box scale, 10 meters wide, 5 meters high, 20 meters deep, and I'm just ignoring the 5. So I'm taking the first and the third elements and using them to scale my floor. So scale $1, $3. Computer is extremely sluggish. All right, so the first thing I'm going to create in my world, now that I've looked at all of this stuff, is someone in class had asked about morphing between different shapes, and I said, oh, it's difficult. But actually, I looked it up because I haven't done it for a while, and it's actually quite simple. So we're going to make a morphing shape. It requires a jit.gl.grid shape. And it requires a special argument that we haven't seen before called @matrix output space 1. So what this means is it's our regular jit.gl.grid shape, but you see the objects aren't appearing here in our scene. Why not? Because they're being output actually as, you can think of them as being output as video. If we take a jit.p window, that object I just showed you that puts a video window in the patch, we can see that there's some kind of actual video information coming out of this object. And what this is these are the coordinates of the 3D object represented as an image. So if I take an adder UI to specify my shape, what we're seeing here is the information of a sphere represented as colors. And if I change it to a cube, that's the information of a cube represented as colors. And here's information of a circle represented as colors. Now, who cares? Well, what it does is it empowers us in a certain way to be able to mix shapes the way we would mix video. So there's a little object called jit.xfade. And what jit.xfade allows us to do is crossfade between 2 video sources. And since we've just converted our 3D objects into video sources, we can pass them into this jit.phys.object. Now, how do we get this graphics back out of the video format? Well, that's a new object, jit.gl.mesh. And this is where we want to put our lighting enable, smooth shading, and depth enable. We didn't need those here because we're not actually sending these objects to the rendering context yet. We're sending them out of the jit.xphase to the rendering context. And we also, of course, need to name our context, which is w_1. And there's my sphere. And if I want to transition this, if I want to crossfade this shape to a different shape, I need the xfade $1 message. And then I send it a floating point value between 0, meaning fully show me fully the left shape, or 1, show me fully the right shape. So let's zoom our camera in on this and take a look at what this looks like. So here's our left shape. If I put a 1 in here, that's my right shape. And as I fade between them, I get a transition between the two shapes. Wrong object. If I switch this over to rotate XYZ, I can rotate this object in space. We see that is a three-dimensional object that is somewhere between a sphere and an open cube. And as I morph it towards the open cube, it becomes more of an open cube. As I morph it back towards the sphere, it becomes a sphere. And if we want to, the only valid values here are values between 0 and 1. So we can click on that floating point number box and just give it a minimum value of 0, a maximum value of 1, and then we don't need to be scared about going over the minimum or maximum values. Crank it all the way up, and it stops at 1. Crank it all the way back, and it will stop at 0. And for instance, I can put a light inside that cube, or inside the sphere. It's a sphere at the moment. And as I open it, I'll see the effect of the light that's inside the object. And of course you can go between all sorts of different shapes, morph between a cylinder and an open cube. It's quite nice. There's our cylinder, becomes an open cube. A little abrupt there at the end. So that's a fun thing. The next thing that we looked at was we looked at the physics and how to turn bodies into physics bodies. So I'm going to encapsulate this. And also, as I think we looked at, there's the objects have a an enable attribute. So if you just want to get an object off the scene temporarily, you can set its enable to 0. Enable 0, and poof, it's gone. But the patch is still there. So what we looked at, and I'm just going to copy and paste this to make it a bit quicker. Is we looked at taking objects and attaching a jit.phys.body object to them. So here I have a grid shape to place it into this world, w_1. And certain functions of the object are taken over by the jit.phys.body, like position and scale. Those are no longer controlled by the grid shape itself. The jit.phys.body has taken over those things. But the drawing portion of it, like for instance the smooth shading, that is still a control we send directly to the jit.gl.gridShape. And then the shape itself is something we want to send to both objects. So there's some things that are being taken over by the physics body, some things we still send directly to the grid shape, and some things we want to send to both. And so I just wanted to give you an example of each one of those here. So where is our there's our cube right there we just created, and you can see it's illuminated from the pink light from above. If I change this to a blue light, the top lighting is going to change, and the white light from the left. Yep, now it's to the right, to the left, and the floor is red because of the jit.gl material. I chose there's orange lacquer as the surface, and then that's combined with a still frame from this video that I paused. So it's all combining to create a pretty sophisticated visual composition. So let's take this cube and make it a sphere, and I'm going to turn off smooth shading for the moment because it makes it a little bit easier to see the way the sphere moves in the physics world. A basic movement through the physics world is by pushing on objects, applying forces to them. So, so we can send an impulse to an object, and the impulse has strength, magnitude in x, y, and z direction. So if we want to push this ball away from us, we'd push it in a negative z direction. So I'm not going to push it left and right. I'm not going to push it up and down. I'm going to push it away from me. And this is something we send to the physics body. It's a message we're sending to the physics body. Impulse space 0 space 0 space -2, meaning give it an impulse away from me in the z dimension. And we see our ball rolling away. And if I want to roll it back, say faster, I can give it an impulse 4 back at me. Roll it back towards me. Impulse -2 rolls it away. We also have torque impulse. And what torque impulse is, that's a rotational impulse. So if I wanted to spin like a top, that would be giving it a torque on its y-axis. And it spins like a top. Because when you're dealing with rotation, XYZ rotation, as we talked about in class, you imagine putting a line through the object in that dimension and spinning it along that dimension. So since X is left and right, we imagine a left and right line going through our object, and it would spin on that dimension. Y is the up and down vertical dimension, so we imagine putting a line through our object and spinning it on that line, and that's what we're doing here. And to spin it on Z would be the same thing as giving it an impulse to the right. And you see, we're dealing with these lists here again, which is, you know, that's why it's so important that you get the hang of the join. Object, because that is how we build lists. So it's a 4-element list, starting with the word impulse and then 3 numbers. So I'll do the same thing here. I can dial in whatever impulse I want. If I wanted to come back to the left, I'll give it a -X impulse and hit impulse. Give it a little bit bigger one. Because remember, join without the triggers argument only sends when it receives something in the left inlet. So I can dial stuff in here all I want. If I want the ball to jump up, that would be an impulse on the z-axis. I can change these values, and nothing is coming out of the join until I send it input in the left input, until I hit impulse. Ooh, that's not up. That's towards me in the z dimension. Pardon me. This is up. There, bouncy ball. And as we looked at, there are a lot more things that you can adjust for a physics body. We've got its damping, which is how quickly a motion damps down or stops. So if we roll it away from us, but we have a lot of damping, so I can't even move it. As I turn down the damping, I have my rotational damping all the way up, so it's just sliding, it's not rolling. But as I turn my rotational damping down, now it rolls eagerly. So damping is two types of damping. There's position and rotation. So the more positional damping it has, the quicker it's going to slow down in its movement. And the more rotational damping it has, the harder it is to make it rotate and keep it rotating. So you see it kind of skids. We also have force, which is like a wind pushing on the object. We looked at that. We have friction, which is how difficult it is to slide an object against another surface. Mass, which is how the object is going to react to gravity. An object with little mass is not going to be pulled as much by gravity as an object with high mass. So you can go in and experiment with these values, and if you want to see them in action, as you now know, you can option click on an object to call up an interactive help file that is a max patch, where you can see some of the effects of these different attributes in action. And you can also get to that help file by clicking the object and going to the help menu. The computer's being extremely sluggish, I apologize. Here we go. Help. Now it's reacting. Help. Select the object. Help. Open jit.phys.body. Help. There's also a reference document that gives a tremendous amount more information, often more information than you even want, on each object. So once we have an object, and remember, if you want to encapsulate, that's great, but it's important to remember that adder UI objects need to go inside the encapsulation. And anything you haven't frozen is going to be reset as soon as you encapsulate. So if I take my lovely sphere and encapsulate it, it's a cube again, because it's just like redrawing the object. But my messages can all stay outside my encapsulation. So go back in here and I had smooth shading off and shape of a sphere. There, back. And now I still have my controls on the outside. And so I can just duplicate this. Oh, cube falls on the sphere. And I'll just leave this one a cube. And so the objects will interact with each other. And there we have it. So there's a lot you can do with this. I mean, you can really think in terms of beginning to create either sculptures in virtual space or virtual architecture. You can do buildings or cities. You can also certainly do games in a 3D setting. You can, of course, make interesting just visual compositions. And if you're interested in sound, it's really fun to utilize the 3D virtual space and objects colliding in the in the virtual space as sound generators, just in much the same way that we built a sequencer using 2D graphics. We can build a sound environment using 3D graphics. So that's it for the tutorial for this week. Build all the stuff that I built. Make sure that you understand it. Email me with any questions, and then we'll have a quiz on this on Monday and an in-class project where you'll get a chance to work a little bit with the graphics. Have a great weekend, and I'll see you Monday.